Today we will continue using the distributive property to expand algebraic expressions, creating equivalent expressions. Later in the course, we will use this skill to help us simplify and solve problems. So let's get started. To multiply 5 times the quantity, 2x minus 4y, we will distribute 5 to both terms within that quantity. We'll end up with 5 times 2x, and bring down the subtraction, and then 5 times 4y. We can then multiply our numbers. 5 times 2 is 10. 10x minus 5 times 4 is 20. 20y. We have created equivalent expressions. The expression 5 times 2x minus 4y is the same thing, or is equal to, 10x minus 20y. For the second problem, we will distribute negative 2. So we're going to negative 2 times 7, and then negative 2 times 5y, and negative 2 times x. So negative 2 times 7. I'm going to bring down the subtraction sign, and then negative 2 times 5y. Bring down the addition sign, and then negative 2 times x. This is negative 14 minus, and then we have negative 2 times 5, that's negative 10y, plus, and then negative 2 times x, that's negative 2x, minus a negative, that's going to give us addition. We can change that to addition. So we have negative 14 plus 10y, and then plus a negative, that becomes minus 2x. And once again, we created equivalent expressions. So negative 2 times the quantity 7 minus 5y plus x is the same thing as negative 14 plus 10y minus 2x. Now in all these cases, I keep the subtraction in, and I just carry the subtraction sign down. But you can also convert subtraction to addition. So instead of 7 minus 5y plus x, we would have negative 2 times 7 plus, and then now we have negative 5y plus x. And then as we multiply these across, as we distribute that negative 2, we have negative 2 times 7 plus negative 2 times negative 5y plus negative 2 times x. So instead of viewing this as subtraction, so here we have subtracting a positive number, we can look at it as adding a negative number. When we do the arithmetic, do the multiplication, we have negative 14 plus, and then negative 2 times negative 5, that's a positive 10y, and then that's minus 2x. Again, we get the same answer. Either method works, depending on how you view and want to work with subtraction. Now let's look at cases where we are distributing a variable. So this time we're going to multiply 2x times the terms within the parentheses. So 2x times 3y and 2x times 5. So we have 2x times 3y plus 2x times 5. Again, when we're dealing with multiplication, the order does not matter. So we can rearrange the order that these factors are written in. So instead of 2 times x times 3 times y, we can go 2 times 3 times x times y. plus, and then we can change this order with 2 times 5 times x. And then 2 times 3 is 6. And then x times y is simply xy. Plus, and then 2 times 5 is 10, times x gives us 10x. So once again, we have equivalent expressions. 2x times 3y plus 5 is the same thing as, or is equal to, 6xy plus 10x. These are equivalent expressions. So now let's distribute x. Multiply x to the quantity 2x minus 3z. So we're going to take x and multiply it to 2x and x to 3z. We have x times 2x. Bring down the subtraction, and then x times 3z. Kind of write these in a different order. So now we have 2 times x minus 3 times x times z. All I did was change the order of the factors. So this brings down the 2, and then x times x, that's x squared. Now we have minus 3xz. X times the quantity 2x minus 3z is the same thing as 2x squared minus 3xz. These are equivalent expressions. So now we're going to multiply x over 3 times the quantity 7x minus 6y plus 2. Again, we will distribute this term to the 3 terms within the parentheses. So the first thing I'm going to do is I'm going to split up this fraction, and I'm going to write it as 1/3 times x, and then times 7x. Bring down the subtraction. I'm going to do the same thing. Write it as 1/3 times x times 6y. And then once again, 1/3 times x times 2. Rearrange the factors because order does not matter in multiplication. Get the numbers together. So we have 1/3 times 7 times x minus 1/3 times 6 times x times y, and then plus 1/3 times 2 times x. Okay, 1/3 times 7, that's 7/3. And again, x times x is x squared. Minus 1/3 times 6, 6 over 3 is 2, xy. Plus, and then 1/3 times 2 is 2/3, x. And then finally, negative 3y times the quantity 5x plus 2y minus 4. Again, distribute the negative 3y to each of the 3 terms within the parentheses. We have negative 3y times 5x plus negative 3y times 2y. I'm going to bring down the subtraction sign, and then negative 3y times 4. So we have negative 3 times 5 times x times y. We typically keep the variables in alphabetical order, so x before y, but if you put y before x, it's the same thing. Bring down the addition. Now we have negative 3 times 2 times y minus negative 3 times 4 times y. Negative 3 times 5, that's negative 15, xy. plus negative 3 times 2 is negative 6. And y times y, that's y squared. Minus negative 3 times 4 is negative 12. Times y. So negative 15xy. Plus a negative, we can change this to subtraction, so we'd have negative 6y squared. Then once again, minus a negative, that becomes addition, so plus 12y. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. So here we're multiplying each term by negative 2. When we multiply by a negative, it will end up changing the sign of each term within that parentheses. So x is now negative 2x. Negative 3y is now a positive 6y. And a positive 7 is now negative 14. And again, what we started with in the problem is equivalent to the answer that's in the box. These are equivalent expressions. For the second problem, we're multiplying by x over 4. So once again, I split apart that fraction, rewriting it as 1/4 times x. And we end up with 3x squared minus 5x over 4. We are multiplying 3y to that expression. And again, we end up with negative 6xy plus 15y squared minus 12y. And then finally, multiplying with a decimal, we have negative 0.25 times 2x plus 3z, resulting in negative 0.5x minus 0.75z. Since we started with a decimal, it's customary to end with the decimal. But another way you may look at this problem is to convert that decimal to a fraction first. So 0.25, that's 1/4, so 1/4 times 2x plus 3z. We do this math, we end up with negative 1/2 x minus 3/4 z. And then we can convert this back to decimal places if you'd like. Sometimes it's easier to work with fractions than decimals, and then other times it's easier to work with decimals instead of fractions. Continue practicing expanding algebraic expressions, and I'll see you in the next video.